Hello, today I will measure an apparent weight of an object in an accelerating elevator to see how does the acceleration affect the normal force and apparent weight of an object. In this experiment, I will have a scale, telephone with an app calculating acceleration, stopwatch and video recorder and elevator. To measure the varying apparent weight of an object, I will put the phone on the scale and put the scale on the elevator. I will first measure the weight of an object while elevator is stopped, and I will call this weight a standard weight. Then I will go several floors down with an elevator and record a video during the trip of the elevator. While going several floors down, at beginning acceleration of elevator will be downward, then zero, and then will be upward while slowing down to stop. While the elevator is accelerating downward, apparent weight of the object should be smaller than standard weight, and apparent weight should be equal to standard weight while the elevator is moving with constant velocity. And then apparent weight should be greater than the standard weight while the elevator has an acceleration upward to stop. From the video that I recorded, I will take the data of apparent weight in every second. And by using these data, I will calculate acceleration of elevator every second. To calculate acceleration of elevator, I will use the equation apparent weight equals to standard weight minus mass multiplied by acceleration. The app on the phone will also be calculating the acceleration of elevator every second. So I will have a chance to compare my results and see my error percentage. The scale normally calculating the weight of the object, but to make it easier for people to use, it shows mass. But we learned what gravitational acceleration of the world does scale use to calculate apparent weight, and by using that value 9.81, we calculated apparent weight of the object every second. As I said in the first part, I will use phone with an app that calculating acceleration every second. And also I will use stopwatch to measure the time, and also I will use scale to see apparent weight of an object every second. In this experiment, I will use an elevator of an Bilkent University's electrical engineering building. And this is the setup that I will use to conduct this experiment. During the experiment, elevator first accelerated downward, then moved with constant velocity and then accelerated upward to stop. While the elevator is accelerating downward, the normal force exerting on the object has fallen, and the apparent weight of the object has fallen from 1.96 Newton to 1.803 Newton around 30 seconds. Then elevator started to lose its acceleration downward, so the normal force and apparent weight began to rise again. From 6 to 11 seconds, elevator has moved downward with constant velocity and zero acceleration. Thus, apparent weight of the object and normal force stayed same. As elevator got closer to finishing floor, it started to brake and gained acceleration upward. When the elevator had an acceleration upward, the normal force exerted on the object and apparent weight of the object has arisen. At 13 seconds, the apparent weight of the object was 2.117 Newton. Then elevator stopped and scale showed standard value of the apparent weight. By using these values and formula, I calculated the acceleration of elevator. And by using the app on the phone, I compared the results of acceleration of elevator, and I plot a graph of them. Error tolerance could be seen in that graph has occurred mostly because of the imprecise calculation of the phone and application.